Okay, so we're going to talk about degrees, minutes, and seconds, put that together with what we've learned about the 6 trig functions to solve some application problems. Now, we're used to dealing with base 10, where we might have 2.5 degrees, and if you see that, you know what that means. That means 2 degrees and then 5/10 of another. In other words, 2.5 degrees. Well, when we're studying trig, oftentimes it's convenient not to think of things as divided into tens. Like we think of, we've got 2 wholes and then we divide another one into 10 equal parts, 5 of those, 5/10. Well, we're going to find it's oftentimes convenient not to divide things into 10 equal parts, but into 60 equal parts. Sort of like we're in base 60. In other words, we might say that we have, instead of thinking of it as 2 and 5/10 of a degree, we might write that this way. 2 degrees, and I'll explain this in just a minute, and 30 minutes. Now, I'm going to explain where I got that from. Every degree you can think of as being divided into 60 equal parts. So here's a degree, 1 degree. 1 degree, each degree is divided into 60 minutes. Okay. Now we're used to thinking of things divided into tenths, right? But just think of having a degree and dividing it into 60 equal parts. So every degree is 60 minutes. Okay? Now, every minute, once we divide a degree into 60 minutes, we could say, well, let's look at a minute. A minute is what we're going to call seconds, 60 seconds. So that's a further division. Okay? So we've got 1 degree is 60 minutes, 1 minute is 60 seconds. Do you see that? So half a degree would be 30 minutes, right? Do y'all see that? So here's what we have on this problem right here. We have 2 whole degrees. Okay, this is how many degrees we have. We have 2 whole ones. Now we want to find out how many minutes. The number of minutes, we just say, well, what fraction of a degree more are we looking for? We're looking for half of it. So I take half of the 60, right? In other words, half a degree, I just multiply 0.5 times 60, and that would be 30. So here's what we have now. We have that 2.5 degrees is equal to 2 degrees and 30 minutes. Everybody understand that? Okay. Here's what we have. We have 2 whole degrees. Now what this decimal tells us is we have a fraction of another degree. That fraction, this 0.5 means it's half. So here's what we do. Here's where we make the conversion. We want to know, well, what is that in terms of minutes? Half a degree is how many minutes? Because we want our notation here to be in degrees, minutes, and seconds. Well, we know that every degree has 60 minutes. So what we do is we take this fraction, 0.5, and multiply it by 60 to give us how many minutes we have. Okay? So half a degree works out to be 30 minutes. Does everybody see that? Okay. Well, let's look at this then. Let's look at how we can just go from decimals to degrees, minutes, and seconds. Let's suppose, in other words, that's what we need to be able to do. Take a decimal, which we're more familiar with, and then write it as the less familiar degrees, minutes, and seconds. And go backwards also. We want to be given degrees, minutes, and seconds and go backward and then go to decimals. So let's just take this one, for example, this first one, 2.75. Well, that, we want to look and see, well, how many whole degrees is that? How many would you say? 2, right? Okay, there's 2 whole degrees. Now, we want to see how many minutes. Well, it's 0.75, it's 75% of another degree, right? Well, in terms of minutes, that would be 0.75 times 60. Now what's 0.75 times 60? 45? Okay. So that's 45. So here's our answer. We have 2 degrees and 45 minutes. Now notice, it's exactly 45. That means we don't think about seconds. Each one of these minutes is 60 seconds, but we're just going to write it this way. 2 degrees and 45 minutes. Okay. Any questions about that? Now, let's look at one that has seconds. On this one, we have degrees, which we have 2 whole degrees. Now, let's look at minutes. We have 70.76 times 60. What does that give us? Somebody work that out for me. 45.6. Okay. Now, notice I've got 45 whole minutes. And then I've got a fraction more. Well, 0.6. I want to figure out, well, how many seconds is that? I've got 45 whole degrees and then and then a fraction more of seconds. Well, so let's figure out how many seconds we have. I take this 0.6 times 60. Now what's 0.6 times 60? 36. Okay. Okay. So here's what we've got. We've got 2 degrees, 45 minutes, and 36 seconds. Any questions about that?
Do they use that with like GPSs or something?
Sure. I mean, this is commonly used. Yes. Yeah. Mm-hmm. Yeah. Y'all have probably, if you studied navigation or bearings, they use a lot of degrees, minutes, and seconds on that. I mean, you've probably seen this notation before.
I've seen it at Grandpa's office.
Mm-hmm.
Minutes are there.
Any other questions about this? Okay. Now, what we've just done is we've converted decimals to degrees, minutes, and seconds. And look at the process. All you do is take the fractional part, multiply it by 60. Keep the whole number part. And you do it until you get, to the second. Now, sometimes when you multiply at the end, you'll get a fraction. For example, let's suppose this had been 36.2 seconds. Just go ahead and keep it 36. Round to the nearest second. If it had been 36.9 seconds, go ahead and round it to 37 seconds. In other words, we're not going to go beyond seconds. Or you could keep it as a decimal. I'm just going to have you round it, though. Okay. Now, let's suppose we have degrees, minutes, and seconds. We'll start off with a simple one. Let's suppose we have 5 degrees and 30 minutes. Just that. In decimal form, what would that be? That's right, 5.5. Because we have 30 of 60, so this would be 5.5 degrees. Now, let's look and see. That's probably obvious to most of you. Well, 5 degrees and 30 minutes, well, there's 60 minutes, so that's half. But now look, if we wanted to be more formal, if it wasn't so obvious to us, 30 is half, that's clear. We could have done this. We could have said this is 5 degrees plus 30 over 60 of a degree, right? And that's the same thing, isn't it? That works out to be the same thing. This is 0.5. Okay? So if you were to just put that in your calculator and work it out, you would get 5.5. If you said 5 plus 30 over 60, you would get 5.5. Okay? Now let's look at this one. Let's suppose we've got 2 degrees, 15 minutes, and 10 seconds. Let's see how we would convert that. Now you think back when you were learning about decimals with base 10. Remember you had the ones place, or well the tenths, the 100ths, the 1,000th, right? So think back and see if you can make a connection here. This is going to be 2 degrees plus 15 over 60. What do you think goes next? 10 over, and this is degrees, by the way. 10 over what? Think about it now.
What if it's 60 squared?
That's right, 60 squared. See, remember how you did this when we're taking decimals and expanding it out, writing it as fractions. Like, recall this. Think about this. 10.75. Isn't that this? 10 plus 7/10 plus 5 over 10 squared. Isn't that what that is? That's when we're dealing with this tenths. But up here we're dealing with 60ths. So notice the similarities here. Now, if you put that in your calculator and work it out, you would get the decimal representation. Any questions about that? So that's how so converting from degrees, minutes, and seconds to decimals is pretty easy. Any questions about it?
Where does it get hard?
Well, this doesn't get real hard. But we're going to look at some a little more challenging ones here in just a second. Any questions about this? Now, let's look at the next step here. Just something right before this one. Let's look at this problem. Let's do some arithmetic with this degrees, minutes, and seconds. Let's suppose we've got 10 degrees, 15 minutes, 55 seconds, like that. And let's add that to 12 degrees, 10 minutes, and 10 seconds. Okay, so we're adding these. Now, just add terms here. We've got degrees, minutes, and seconds. Let's add likes to likes, right? We've got 55 and 10. What is that? There's 65 seconds, right? Now, how many minutes are there? 25 minutes. And how many degrees? 22 degrees. Now, would you call that finished?
No.
What's wrong with it? That's right. We shouldn't have 65 seconds because we can make this a little neater. I mean, there's nothing wrong with that really, except it just doesn't look good. That's right. Let's do this. Let's take 60 of these seconds and add another minute over here. And how many seconds does that leave us? 5. That's right. Now that looks a little better.
Would you need to write that 5 or 05?
5.
Just 5? Okay.
Mm-hmm.
I thought I'd ask.
Okay. But you think it wouldn't because you think of it as 65 seconds, and you just take 60 of those. I mean, it's not a fraction; it's a whole 5 left over. Okay. Any questions about that? So see, you remember back. So working with this is a lot like working with base 10. Okay. You just have to think 60 instead of 10s. Now let's look at another one. Let's suppose we've got this. Let's suppose we've got 4 degrees, 15 minutes, and let's subtract from that 2 degrees, 4 minutes, and 5 seconds. Now, how would you do that one? What word comes to mind when you have a situation like that?
Carry 1 over.
Huh? Well, what comes to mind when you have this situation? What comes to mind when you have that situation? Borrow. That's right. That's right. Remember, we borrowed. We took 1 away from this, and in other words, we took a 10 away from this, right? And we put it over here. So now we've got 14.
So on the top one, that would make 60?
That's right. That's right. So, see, what we did was, back when you learned this in elementary school, we took 10 away from this, and now we only have one 10. We took that 10 and put it over here. And that was fine. So that's what we're going to do here. We're going to rewrite this as 4 degrees, 14 minutes, and 60 seconds. Just like when we borrowed back in elementary school, we took 10 away, one 10, and made it 10 ones over here, right? Put it in the ones place and wrote. So that's the way we're doing here. So we got minus 2 degrees, 4 minutes, 5 seconds. Now we can do our subtraction. Looks like what we're going to do is have subtract here. It looks like we're going to have 55 seconds. Okay. We're going to have 18 minutes.
No, it would be 10.
That's right, subtracting. I owe you a sticker. Okay, 10. And then 2 degrees. Any questions about that? No questions? Okay. Now, we've learned about the 6 trig functions, made some observations about those, and we've learned about degrees, minutes, and seconds. Do you have any questions about any of that so far? Okay. Now, what I want to do is show you some calculator techniques for dealing with these things. Let's suppose that we want to calculate the sine of, 15 degrees or something like that. Well, first of all, now we haven't been introduced to anything but degrees. We haven't talked about radians. So at this point, we need to make sure our calculator is in the mode to deal with degrees. The way you do that is you come up here to modes, second column, top, just press mode, and the third row down, you'll see you can choose either radian or degree. We know nothing of radian right now. So you just want to go down and make sure that degree is highlighted. So just arrow down, hit enter over degree, and make sure that it's highlighted. And then once you do that, just do second, quit, and come back to your home screen. Okay, has everybody got that far? Now, let's just compute something like sine of 15 degrees, let's say. Just press sine right here, and then put a 15 in. And hit enter. And there you have it, sine of 15 degrees. Now what about, what would cosine of 85 degrees be? I mean cosine of 75 degrees. Did you need your calculator for that?
No.
Remember, it's complementary, right? Okay. So we knew that right away. Cosine of 75. See, this just goes back to confirm what I said earlier. You got complementary angles, cofunctions. So, any questions about that? Now you can put the most comfortable way to work with these is when you're in decimals. So like if we want tangent of 2.75, for example. I mean, you just type it in exactly as you see it. Okay, everybody see that? Now, let's suppose that we don't have 2.75. Let's suppose we have something like 2 degrees, 4 minutes, and 13 seconds. Well, let's do that. Let's do tangent. Now, what did I say? 2 degrees. So let's type. Okay, so here's 2. I just type in a 2. Now, let's watch what I do now. I need to get these symbols for degrees, minutes, and seconds. So I type in the 2, and then I come up here, and I'm going to do a second function. And then right over here at apps, there's a thing called angle. I'm going to do second angle. And look, right up at the top is a wee circle indicating degrees. So I'm going to hit enter, and there's 2 degrees. Now, how many minutes did I say? 4. Okay, so I type in 4, and then I go second, apps, and number 2 gives me minutes. And how many seconds? 13. So now 13. Now, I don't know if there's a second key anywhere on here. I always use this double quote, or this quote down here. You see there's a quotation. Yeah, that's. I think it's intended to use that. That's why they don't put a second symbol on there. So here's what you do. You alpha plus, and then go ahead and close your parentheses, although the closing of the parentheses is not necessary here, since I'm not doing anything after it. And I hit enter, and there it is.
Whoa.
There's the decimal answer.
I'd say that's so cool.
Yeah. Now, you could... so working, performing these operations with your calculator is easy. Just knowing where the buttons are when you're dealing with degrees, minutes, and seconds, making sure you're in the right mode. It won't be long before we start talking about radian measure. And then it's going to become an issue. Which mode do I need to be in, degrees or radians? Okay. But right now you don't have to worry about it. You're always going to be in degree mode until you hear the word radian when I'm explaining it. Okay? Any questions about that? Okay, so let's put this what we know about the trig functions and what we know about degree measure, and let's suppose and put them together and see if we can find the missing parts to this triangle. In other words, what we're given here is we're given the hypotenuse, we're given degrees, minutes, and seconds for that angle, and we don't know what this angle is up here. I'll call it beta. I'll call this side x and this side y. We need to find those 3 parts. Now, what is the most straightforward, and we're assuming this is a 90-degree angle, by the way. I forgot to write that down. What is the simplest thing to find right away, most straightforward?
The 90 degrees.
Well, this beta, right? Because we know that these angles have to add up to 90. So look, here's what we know. We know that beta is equal to, well, this plus this have to equal, well, one of the things we can do is we know that if we take, since this plus this has to equal 90, so what would you do? How would you solve that?
90 degrees minus...
Yeah, that's right. Just say 90 minus this, because beta plus this must equal 90. So then what would you do next? Just subtract, like Jordan said. Just subtract this from 90, and here's what you have. You have 90 degrees minus, look at this, 12 degrees, 15 minutes, and 4 seconds. Okay? Now what would you do? You don't have any minutes or seconds up here, so what would you do? Yeah, just borrow. Make this 89 degrees. So let's go on over here and see what we've got now. We've got 89 whole degrees, and then I've got 60 minutes, and I still don't have any seconds. We'll take care of that in just a second. Let's just see where we stand right now. 12 degrees, 15 minutes, and 4 seconds. Okay? Minus. Now what would you do?
Borrow again.
Borrow again. That's right. So now here's what we've got. Finally, we've got 89 degrees, 59 minutes, and 60 seconds. Now we're ready to go to work because we've got something in each place so that we can subtract. Okay, so what does that give you? How many minutes do we have here? I mean, how many seconds? Okay, 56. So there's 56 seconds. How many minutes?
44.
Okay. 44. And then how many degrees? 77. Okay, so we've got the beta. We've got beta. Now, how do we find y? How can we relate y to information that we've been given? How can we do that? Do you know of any way to relate an angle and its opposite side and the hypotenuse? Sine, that's right. So here's what we know. We know that sine of 12 degrees, 15 minutes, 4 seconds equals y over 7. So all we have to do is write down the relationship that we know. We know that relationship exists. How would you...
we multiply.
That's right, we multiply. So now, here's what we've got. We've got y equals 7 times the sine of 12 degrees, 15 minutes, and 4 seconds. Now, what would that give you in your calculator? Okay? And that's going to give you what y is. Now, while Josh is doing that computation, how would you find x? Yeah, you could use Pythagorean theorem. I wasn't even thinking about that. What's another way you could do it with the trig functions? Is there any trig function you could use?
1.48.
Yeah. Look, what you can do is, this is the adjacent side, right? You can work this the same way you work this one. Look, if we say this, okay, the x, notice what we have here. We have the cosine of 12 degrees, 15 minutes, and 4 seconds. That's equal to the adjacent side over the hypotenuse. So it's pretty much the same way. Now, notice all you have to do, if you've worked this out with your calculator, it's the same thing. You just second enter and replace the sine with cosine. Right? Everybody see that? And what we've done there, we were given an angle in one side, the hypotenuse, and from that we found everything else. Okay? Are there any questions about that?